Hey guys, what's up? See, I'm here with the next topic, and what this topic is called, this is called invert sugar, and this is related to the sucrose that we were doing, we've been doing for the last one or two lecture. Now the question is, what is this invert sugar and what are its important? The very first thing I'm going to tell you, it is something, something very, very important for your board exam. I have seen almost like every year, this particular, topic coming out as a question in the board exam. Now, what is invert sugar? Let me introduce to you. Sucrose in its dry form is a dextrorotatory substance, but after it is hydrolyzed, it breaks into alpha D glucose and beta D fructose. So after it breaks into glucose and fructose, the overall rotation changes from dextro to levo, right? And therefore sucrose in its aqueous form is also called invert sugar. So let's do this in detail and try to find out what I'm trying to get you to. But remember, this is really interesting and at the same time very important. So like we know, sucrose has a formula of C12H22O11. So this is your sucrose. Now what you do know that this is a dextrorotatory substance. This is a dextrorotatory substance and therefore it has a plus sign, right? Now after you dissolve it in water within a container with a small amount of acid, like you do know, this breaks into glucose C6H12O6, and this is again a dextrorotatory substance. This is again a dextrorotatory substance, so it also has a plus sign. Along with that, what you also obtain is a fructose molecule. Fortunately or unfortunately, the formula remains the same because it's a isomer. So C6H12O6, that is representing the fructose. But you do know that this is a levo compound. This is a levo compound. What that means? It has a minus sign. Now the question is, how are we going to prove that the sucrose is a, invert sugar? So I tell you what, this has a rotation of positive 66.5 degree. You need to understand that this has a rotation of 66.5 degree, towards the right. But this one has, just pay attention, this one has, 52.5 degree again, and that's also with plus sign. So this is the rotation given by the glucose. However, the rotation given by fructose is minus 92 degree. Now you might have a question where these values are coming from. A very simple answer is that it comes from the experimental evidence, right? So what that means, when you do this experiment of hydrolysis of sucrose, you get to know how much the plane polarized light is rotating. Initially it is rotating by 66.5 degree, then the glucose one rotates to 52.5 degree towards right. However, the fructose rotates negative 92 degree. What that means, this will rotate toward the right, this will rotate to the left. Now what is the overall change? But let me explain you in a slightly different way. Suppose I'm taking a container here, right? Suppose this is a container, right? And you have a sucrose solution here. You have a sucrose solution here. Sucrose solution. Now, what you do when you are passing plane polarized light? When you are passing plane polarized light, this appears to be, bending towards the right. Just pay attention. I'm trying to, make you go in most simplest way possibly I could make. So suppose this light, is moving towards the right by 66.5, right? 66.5 degree. Now, what happened after some time, when you observe that this has not only glucose, just pay attention, this has not only glucose, but it has also fructose. This one also has fructose. So what happened? The overall rotation goes something like this. Let me, draw it first. So the rotation goes something like this. This is a visual, I might be creating on my own. So that's why So what is happening? There the rotation is 66.5, but now the rotation comes out to be minus 39.5 degree, right? Now the question is, it started with 66.5, but the overall rotation is now towards the left, which is 39.5. Why it is happening and how it is happening? That is the very important thing. I'll tell you what. You know, this the sucrose itself is dextrorotatory. However, the glucose is, dextro, but the rotation given by the fructose is way more than the rotation given by the glucose. So what happened actually? This value is coming. Let me tell you, this value is coming, by this particular mathematical calculation, minus 92 and plus 52.5. So this gives, this gives a value of 39.5, minus 39. So what is happening here? Initially it was 66.5, but after it converts into glucose and fructose, the overall rotation changes to minus 39. Let me, show you right here. So this is what is happening. Initially it is 66.5, but then it goes to minus 39.5. So there it appears to be as a dextrorotatory because it is a positive sign here, and this represents a dextrorotation. But there, the overall rotation is changing towards the left side because of this minus sign. So what happened? Sucrose, after it is dissolved and converted into an aqueous solution, the overall configuration of sucrose changes from dextro to levo, and that's the reason sucrose in aqueous solution is also called invert sugar, right? So I hope I made you go as simple as as it could be. In case you have problem, let me repeat back. When sucrose solution is observed, and when PPL is passed through the sucrose solution, the rotation is observed to be 66.5 degree towards the right. But after some time, sucrose overall rotation changes to minus 39.5. Why? Because the sucrose converts into glucose and fructose. Because the sucrose breaks into glucose and fructose. The glucose rotation is positive 52.5 degree. However, the fructose rotation is minus 92. So the sum of the rotation given by this particular mixture remain only minus 39.5. So what is happening? Sucrose in its dry form was dextro, but sucrose in its aqueous form is now a levo. That's the reason sucrose in its aqueous solution is also called invert sugar, because the overall configuration is changing from dextrorotatory to the levorotatory. So that's that's the something So this is something I wanted to make you go about the invert sugar and the sucrose also. So with this I must wind this here. I don't want to make this go longer, way more than 10 minutes or something. As I would say, thanks for watching, take care, and in case you like what I just helped you out, do one thing. You can share with your friend. Definitely do let me know whatever way you opt for. You can mail me, you can call me, you can leave your comments and all. And with that, thanks for watching and take care.